Hello, this is a little video for lesson 6.3, understanding the distribution of our different histograms and the sampling distribution. So this question here, it says the number of golf balls Ryan loses when he plays around has a population distribution as shown in the probability histogram below. The population mean is right here, 1.22 balls. And you can see the population distribution is skewed left. So that's that. Now it says we're going to take different size samples. So now we're looking at the sampling distribution. So now we have a sample size of 3, and they want us to decide what it's going to look like. So if you go back to what we did in the 6.3 video for the notes, it means that our mean is going to stay the same. So our mean should still be at about 1.222. But it's not going to still be totally less skewed. It's going to start to look a little bit symmetric because when we start taking larger and larger sample sizes, it's going to look more and more symmetric, even though the original population is skewed. So I had choices here. This is the choice that we're making. It's still a little bit less skewed, but you can see that my center is at 1.22. That's what I'm looking for. Then they increase it to sample size 8. It's not looking really skewed anymore, but we still have to have the center at 1.22. And our standard deviation is getting smaller. Even though we don't know what it is, it's getting more and more symmetric and tighter around the mean. And then once we get to a sample size of 30 or bigger, remember we talked about that the distribution will look normal and symmetric no matter what, because we have a very large sample size. So once we get to sample size of 30 or more, it's going to still be at 1.2, see that? And it's going to be very symmetric. So let's try another one where we don't have the answers. So this says the number of used cars sold in a summer week at ALEKS Auto has a population distribution as shown in the probability histogram below. The population mean they gave us is 2. So the number of cars she sells in a week is about 2. And it's a uniform distribution. They sell the same number, 0 cars as 1 car, as 2 cars, as 3 cars, as 4 cars, and the average is 2. So it says, what would the sampling distribution look like if we take samples of size 2? So it's still going to be somewhat uniform, but our mean should still be at 2. So let's look at the options. So we have this one that's right skewed. We have this one that's in the middle, and then this one that's left skewed. Okay, and then let's just go look at our choices here. So we're going to increase our sample size to 7, and then here's our options here. But remember, our mean has to be at 2. So that's where our original mean. So that's how we're going to make our choices. So let's go back to our choices here on, our first choice here. The center, the mean does not look at 2. It looks like it's over here because it's a skewed right. This one has a mean at 2. This one does not have a mean at 2. It's higher. So it's going to be the one where the mean is at 2. It's still pretty spread out because it's a small sample size, but it's still at 2. Okay, we're going by the mean, not the sample size. The mean is at 2. So now let's go to sample size of 7. We're looking for a mean of 2. So let's go to the first choice. So the first choice, the mean is definitely closer to 1. This one, the mean is definitely closer to 3. This one over here, the mean is at 2. So we're choosing the one that's the mean is at 2. And you can see that it's becoming more symmetric and closer to the center. Now we have a sample size 30. So this one, again, should still have a mean of 2. So let's look at our choices. We've got this one. The mean looks pretty much at 2 here, closer to the 1.8 here. Let's look at this one. That one, the mean is definitely below 1.2. And then this one, the mean is definitely more like 2.8. So we're going to the one that is at 2. That would be this one. So let's check our work. And we are correct. Let me know if you need any other help.